Welcome to FMSP Online Revision. This session is for OCR D2 and the topic that we're going to be looking at is dynamic programming. So we'll start by having a look at the specifications. So candidates should be able to understand the concept of dynamic programming, working backwards with sub-optimization. So that's really just reminding us that at each stage you want the best strategy from that point. And then in Part B, use stage and state variables, actions and costs. And Part C, set up a dynamic programming tabulation and use it to solve a problem involving finding a minimum, a maximum, a minimax or a maximin. So we'll have a look at an exam question and see if we can draw out some of those points. So we've got a question here about Army truck driving course that includes several bridges. The start and safe point just after each bridge have been given stage state labels. The number below each bridge shows its weight limit in tons. So the Army cadet needs to drive a truck through the course from start to finish, crossing exactly 3 bridges. And we're asked firstly to draw a network using stage state labels given to represent the routes through the course. The weights on the arcs should show the limits for the bridges. And then having done that, it says the cadet wants to find out the weight of the heaviest truck she can use. So which network problem does she need to solve? And then in Part 3, we've got to set up a dynamic programming tabulation to solve the cadet's problem. Write down the weight of the heaviest truck she can use and write down the stage state labels for the route she should take. So let's just see how we're going to tackle this. So the first thing we need to do is to draw a network. So we've got on this map, we've actually got the stage and state variables that we need to use. So I'm going to start by here we've got a start 0, 0. There are 2 possible bridges that we could take. We could either take this bridge here with a weight limit of 9, or we could use this bridge which has a weight limit of 7. So those are going to be my 2 arcs coming from the start. When we use this bridge, we then have a choice of 3 bridges with weight limits 6, 7 or 8. So we've got 3 actions, 3 arcs coming out here. And we also have, in the same sort of situation, if we used this bridge with a weight limit of 7, again we could still use either this bridge or that bridge. And once we've actually got there, whichever of these 3 bridges we use, to get to the finish we have to use this final bridge which has a weight limit of 10. So if we can just remember also at this stage, the states that we're talking about are actually the nodes here, and the arcs are the actions. The weight on the actions is the cost, if we need that. And remember that the stage variable, in this case a 1, is the maximum number of actions to get from a state to a final state. So for example here at the finish the stage variable is 3 because the maximum number of actions we need to get back to the start is 3. So we'll complete our network here. So this is a completed network, just including this last stage. So for that you actually got 3 marks. So 3 marks for a completed network. There was a mark for the correct sort of structure as long as you had a reasonably good structure. A method mark for assigning the weights, so it's important that we add those in. And then an accuracy mark if it was totally correct. So it then goes on, the cadet wants to find out the weight of the heaviest truck that she can use. So which network problem does she need? So basically the problem is about minimum weight limits. What we're trying to do is we are trying to maximize the minimum value. So it is a maxi-min problem. So if we just write that in there, you need to understand that it is a maxi-min, maximizing the minimum value. And then in part 3 we're asked to set up a dynamic programming tabulation to solve the cadet's problem. Write down the weight of the heaviest truck and the stage and state labels for the route. So we'll start by drawing up some columns. So we'll have a stage and a state. We'll have our actions, and I'll call this just our working column, and then we have the maxi-min. So you're likely to start by drawing up a table, I would think with 5 columns in it like that. So stage 2, there are 3 states, 0, 1 and 2, and it doesn't matter which of those, which action we use, they all have to use this bridge which has a weight limit of 10. So at this stage our maxi-min is 10. So that would be the first sort of the start of our table, if you like. So we will go on to the next slide and have a look at how we're going to continue that, and I will just put those values in again. And we had our suboptimal maxi-min is 10. We then at stage 1, and we have 2 states, and each of those states has 3 actions, so I've put the 3 actions down, 0, 1 and 2, again starting from the top. So 0 will have an action of 6, but of course that is followed by a 10. Now we want the minimum of those, which is a 6. Or we might take action 2, which had a weight of limit of 7, and that would be followed by 10. So we'll take the minimum of that, which is 7. Or we might take action 2, which has a weight limit of 8, followed by 10, so the minimum of 8. So we're taking the minimum in each case, and what we want is the maximum of the minimums. And we can do the same thing now from 1, 1, state 1. And again, you've got 3 actions, 6, 7 and 8, followed by an action of 10. So similar sort of figures here. We want, again, in each case, we want the maximum of the minimums. So again, our suboptimal strategy at that stage will be 8. And then we come to the final state, which has got 2 actions. So if we use action 9, then that will be followed by the maximum from the previous one, which is an 8. So we want the minimum of that, which is an 8. Or alternatively, we might have used action 1, which meant that we used the bridge with weight limit 7. But again, from the last stage, we know that we will then have the maxi-min there is an 8, so we'll have an 8 here. So the minimum there is a 7. So the maxi-min at this stage is going to be 8. And that means that the heaviest truck that we're going to have to be able to use will be 8 tons. It's important now that we can just work our way back and see how we're going to actually do it. So by doing action 0, that will take us to 1, 0. So we'll come up here. So we're using 0, 0, and that is going to take us to 1, 0, and 1 naught then is going to take us, we've got that from action 2, and that's going to take us back up to here, which is 2 2. So we've got 2 2 and 3 naught. So as long as you can see here, we've sort of used action naught, and here we've used action 2, and here we've used action 3. So you just need to be able to work your way back through that table, and the heaviest truck that we're able to use is 8. So we'll just complete that on this slide. So this was 8 tons. Oops, not very clear, but I think we'll be able to read that. And I'll just put that route in again. It was 0 0, which then went to 1 0, which went to 2 2, and then 3 0. So if we can just go through the marks for the tabulation, there were actually 9 marks for doing that tabulation. And you got 1 for starting off your table, and you would either have with either 4 or 5 columns. I think most of us would use 5 columns, but it did say you could have 4 or 5 columns. And for getting your stage and state columns correct, you got another mark. You also got a mark for getting your actions correct, so this column here. And then once we came into doing the working of it, you got a method and an accuracy mark for getting your minimum values and the maxi-min for stage 1 and 2. And you then got a method and an accuracy mark for getting your minimum values and your maxi-min at stage 0. And so that's 7 marks, and then you got a mark for 8 tons and a mark for your route. And remember, it did say write down the route using stage and state labels, so that's what we wanted there. So I'm going to finish the session here and just remind you that, as always, it's really important that you work through lots of questions. Dynamic programming questions can vary in the difficulty, so you do need plenty of practice in making sure that you can set up your table.